Greetings, math fans. All right, so this is our AP problem. It's called the runners. It's actually a problem we use quite often. Just a good AP problem that was from many years ago. So let's take a look at it. Well, we're given two things here. First of all, it even says on here, two runners, A and B, are on a straight racetrack. T is between 0 and 10 seconds. And the graph above, which consists of two line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of runner B is given by the function v of t equals 24t over 2t plus 3. Okay, so basically we're kind of looking at, we're investigating graphs, we're investigating functions, being able to obviously probably take the derivative, because that's what this is all about, right? Find the derivative or find the slope of a line. Okay, so let's look at the first question here. Find the velocity of runner A and the velocity of runner B at time equals 2 seconds. Indicate units of measure. All right, so, well, for A, again, let's look at the graph. And if I'm looking for an equation for that, because this is the velocity graph, and do you guys agree? So this is going to be A. For runner A, we need to come up with the equation for that line, and then at t is equal to 2 seconds, plug it in. So do you guys agree? I mean, basically, it's if I look at the slope of this line, the slope, it's change in y, which is, look at the point here is 3 comma 10. So it's going to be 10, your equation is y equals 10 thirds, right? You go over 3, 10 thirds x. So that's the equation, and now we need to do that at 2 seconds. So it's really, if I do it in terms of t, let's move this down a little bit. That's our equations, right? V of t is equal to 10 thirds t. And so it's 10 thirds times 2, which is 20 thirds. And so my velocity at 2 seconds equals 20 thirds. And they even told you to be careful of units, make sure you have that in there, and it's meters per second. All right? And then runner B is actually even easier, because you're given an equation, V of t is 24t over 2t plus 3. So it's basically V of 2, you're just plugging it in. 24 times 2, don't have to do anything fancy because you're given the velocity equation, over 2 times 2 plus 3. Okay, so V of 2 is 48 over 7 meters per second. Okay, pretty easy. B, it says find the acceleration of runner A. Well, what is acceleration? Isn't it the first derivative of velocity? So my equation, well, I'm going to erase this now here so we can see everything. So this is B. And the velocity, so this is runner A again. So we have V of t. We already said that was 10 thirds t. So A of t is the first derivative of V of t, or the derivative of V of t, which is just 10 thirds. Do you guys agree? So it's constant. So I know it doesn't matter what it is. So if I said A of 2 seconds is just 10 thirds, again, meters per second squared now. Okay, pretty easy. And I want to find the acceleration for runner B. And what do you have to do for that? Well, A of t, again, is the first derivative, so we're going to do, so let's do V prime of t. So that is equal to, use the quotient rule, so it's the bottom, 2t plus 3, times the derivative of the top, which is 24, minus the top, 24t, times the derivative of the bottom, which is 2, over 2t plus 3 squared. Okay, and can you simplify it? Yeah, but why not just plug? Why don't we just do V, or this is acceleration, so A of 2. Just put it in there, right? And if you plug all that in there, I'm not going to do it now, but you guys can. You get 72 over 49 meters per second squared. Okay, the only thing to be careful about is using parentheses, and maybe you want to use parentheses on top here and then parentheses on the bottom, or hit equals after the top. Just be careful. Okay. Okay, then 2C, it says find the total distance run by runner A and the total distance run by runner B over the time interval 0 to 10 seconds. Indicate units of measure. So going back to the original problem here, math fans, we had our velocity equation that we came up with. So V of t, if you remember, from part A was 10 thirds t. Okay, so really what I'm trying to do is I'm trying to find my position equation. And this is, of course, between 0 and 3 seconds. Okay, because it's different. It's a different graph between 3 and 10 seconds. So we've got to investigate 0 and 3. But it's an equation, and I want to know the position, how far it's gone. Well, we're going to do something called an antiderivative. And we're going to talk a lot more about that next year, or your teacher, whoever's going to teach you that, in Calc B, and that is integral calculus. So the integral is the antiderivative. Okay, and so what we're going to do is let's do a little example here. If I said y equals x, and I want to do the antiderivative, so let's call this y prime, and so y is equal to, well, think about it. You definitely have to increase the power, and I divide it by that number that I increase the power. Because watch this, if I take the derivative of this, doesn't the 2 come in front and I reduce the power by 1? So I get y equals x. So that's the deal. I take, and we'll learn this soon. We'll talk more about this. But you, again, increase the power and divide it by the exponent. So if I have, let's do another example here, y equals, let's just say x cubed. Let's say y prime is x cubed. To find the antiderivative, I raise it to 1 power and I divide it by 4. So again, if you take the derivative of that, you get 4x to the third over 4, which is x cubed. Okay, so let's go back to this guy here, right? Do you guys agree? I'm going to say it's 10 thirds t squared divided by 2. So, or times 1/2, right? So if I cancel some stuff out here, that's a 5 and a 1. So you really get s of t is equal to 5t squared over 3. That's the position equation from 0 to 3 seconds. So what I want to do with this guy is put the value in. It's against my position. How far did I go? So it's 5 times 3 squared over 3 minus 5 times 0 squared over 3. And of course that's 0, which is kind of nice. And so that's 9 times 5, 45 over 3. And that equals 15. That is your change in position from 0 to 3 seconds. Okay? And then I also want to figure out my velocity then from 3 to 10. Well, if you look at the original graph, do you guys agree the velocity is constant at 10 meters per second, right? Because going from, it's a horizontal line. So from 3 to 10, it's going 10 meters per second. And think about that. So V of t equals 10 meters per second for 7 seconds. So do you guys agree? It's 7 seconds is going to be 10 times 7. Okay, so it's going to travel 70 meters in that amount of time. All right, so I have two values here. I have 70 meters and I have 15 meters. I didn't write my units there, 15 meters. And basically I'm just going to add those together and I get 85 meters that I have traveled. Okay, so that is A, runner A. Now, runner B, it says also find the distance. Basically, you have to take the antiderivative of that equation, V of t. We don't really know how to do that yet. It's actually a lot more complicated than it looks. So we're not going to worry about that part. That is more saving, you're saving that for Calc B. and we're just going to do that part of it. So you can really find it when it says the total distance of B, just cross that off, and we just found the total distance from A. Okay? But again, just kind of look at it, right? And you can figure out, we actually, like I said, create an equation for that one. And this one, since it's constant, this part right here, we just know we're going 10 meters per second for 7 seconds, so that's 70 meters that we've traveled. Okay? So anyway, that's the runner's problem, your first AP problem. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.